you can always take a bit of a clue as to what things are by looking at the word and thinking about, well, what do I know about this? Now, there are two important words that we use, one more common than the other, that both have the same kind of basis as this word. Okay? The more common word is cryptic. What does cryptic mean? If I say, ooh, that's kind of cryptic, right? It generally means, can you give me a synonym? Mysterious, confusing, right? Unclear. So that's why we have cryptic crosswords. Right? There's crosswords and they make sense, you know, like here's a rule. And then there's cryptic crosswords. I don't know if you've ever read the clues for a cryptic crossword. It's just like, is this, what is this? I don't even like, you know, it just doesn't make any sense. So cryptic is about mysterious or unclear, right? Now, that's an adjective. The verb that we would attach to this is the word encrypt, right? So if cryptic is mysterious, then to encrypt, right, is to make something mysterious, right? To make it cryptic. And cryptography is the art and science of encryption, right? Of how do you take something which is sensible and meaningful and make it into something that is hard to understand, right? Why would you ever want to do that? Why would you make something that's clear into something confusing? Why would you do that? Yep. Good. To make the truth, right, harder to find or harder to see. Okay? So that's why I like to call it the art and science of keeping secrets. I think that's the simplest way to understand it, right? You've got ideas, you've got truths, you've got facts, but you don't want everyone to know. Okay? So a classic example of this was in the Renaissance, right? You had people like, who did you have? You had your Da Vinci's and your Raphaels and your all these incredibly smart people, right? And they made these discoveries and they invented things, but they didn't want people to know what their discoveries and inventions were. Okay? So they would encrypt them. They would write them backwards or write them in code. Okay? Or they would use these things called ciphers. Okay? Now this is important. This is our first subheading. Okay? What's a cipher? A cipher is a tool, right? A mathematical tool, which is why it comes under maths, right? For how to encrypt something. Okay? It's a very simple idea. Okay? So there's a whole variety of ciphers, and I'm only going to teach you about a very few number, just the ones that are simple enough to wrap our heads around. Okay? So the first kind of cipher is a substitution cipher. Okay? And we're all going to do one today. Okay? A substitution cipher is very simple, right? You've got letters. We have 26 letters in our alphabet, right? A, B, C, D, and so on. Okay? So the simple idea behind a substitution cipher No, it's okay, you deserved it. The simple idea behind a substitution cipher, as the name implies, is you're going to take all of these letters and substitute them for something else. Okay? Now the way that we do it, and the reason why it comes under maths, is because all of the letters, all 26 of them, can be very easily numerically represented. Right? So we can call this letter 1, letter 2, letter 3, letter 4, and so on. Okay? So the simplest, most famous kind of substitution cipher that I'm going to teach you about today is called the Caesar Cipher, because apparently the Romans used to do it. Okay? As you'll discover, it's actually not that good. It's not very good as a cipher. It's not very good at making things mysterious, right? It's very easy to break, right? But that's part of the reason why it's easy for us to wrap our heads around. Okay? How does the Caesar Cipher work? It uses, if you remember this, or you might not remember it depending on what you did in the last few years, it uses a branch of maths called modular or clock arithmetic. Could you raise your hand if you have ever heard of modular arithmetic? Hands up straight. It's like, I heard about it, but do not remember. That's okay. All right, hands down.
Oh, is it the mod thing? Oh, yeah.
Yeah, so
Oh.
modular,
Yeah.
short for, we use the word mod to abbreviate it, okay? I will teach you how modular arithmetic, and you'll see why it's called clock arithmetic. I'll show you how it works. It's really easy, okay? The idea of modular arithmetic is taking remainders, okay? Okay, so this is a new subheading underneath the Caesar Cipher to show you how it works, okay? So we might say have division under, and you pick a number, okay? So say I want to do modular arithmetic with a base of 5, okay? So I'm going to work out the remainders after dividing by 5. Okay? So this is really easy. The way I would write it is I would say, for instance, okay, what's 1? When you divide by 5, how many times can you fit 5 into that? Not a trick question. The answer is you can't fit it any times, right? So if I say mod 5, after taking out 0 lots of 5, what's left? And the answer is just the 1, right? So 1 mod 5 is just 1, okay? 2 mod 5 would just be 2, and 3 mod 5, and so on, okay? But where it starts to get interesting is when you hit 5. Okay? Because 5 mod 5, what's the remainder when you divide by 5? And the answer is 0, right? Okay, and you can keep going, right? Let's do a bigger number. Say, because I picked 5, it's very easy. So if I say 23 mod 5, you just have to take away all the multiples of 5, which is 20, and that leaves you with 3. Okay, simple. So, how does this apply to this, right? We are going to choose a number, any number you like, right? Actually, let's pick 5 since we've been talking about it, okay? And for all of these numbers, I'm going to add that number on, okay? So, for instance, this would become 6 and 7, 8, 9, and so on, okay? Now, here's what I'm going to do. I'm going to replace, I need a few more letters here, E, F, G, H, I, J, K, that'll do. So everywhere I see an A, right, I'm going to replace it with the 6th letter, which is F, right? Everywhere I see a B, I'm going to replace it with the 7th letter, which is a G. And you can see what's happening, right? Now, why is modular arithmetic important to this? Because so far all I'm doing is adding numbers. Well, as I add, things are fine when you go 10, 11, 12, and so on, okay? But eventually, right, you're going to hit letter 25 and then letter 26, okay? Now, quick question for you. See how quickly you can work it out. This means, right, when I see an A, when I see the first letter, I'll replace it with the 6th letter. What letter will I replace with a Z? What number would it be? It would be the 21st letter, right? The 21st letter here, I will replace with the 26th letter, which is a Z. So what is the 21st letter? Is it T? Let's see. T, U, V, W, X, Y, Z. So 26, 25, 24, 23, 22, 21? Did I count right? Yeah. Okay, so when I see a U, right? When I see a ... U, that's letter 21. I should replace it with letter 26. And my cipher so far is fine. But what happens when I see a V? Okay, so that's letter 22. So when I add 5 to it, I get 27, but I don't have a 27th letter. So what I do is I replace it with 27 mod. What should I do it by? I should do it by 26, shouldn't I? Because I have 26 letters in my alphabet. Okay? So this will take me all the way back to 1. I should replace a V with an A, which I guess would mean I would replace a W, which is letter 23, with the second letter, which is a B. And you get the idea. X, Y, and Z, which of course should be replaced with an E, right? Because the first letter over here is an F. So it comes around, okay? So does that make sense? See what's going on? So in fact, Caesar ciphers can be made, and you can actually construct one for yourself, by having 2 concentric circles, right? On the inside you have all the letters of the alphabet, right? On the outside you have all the letters of the alphabet, And then what I would do is I would rotate one of them, right? So it's shifted along, or +5. So this is often also called a shift cipher. Okay. So here's what I would like you to do. Okay. I would like you all to write out a message. Okay. And then I would like you to choose a letter. Choose a letter, right? Sorry, not choose a letter. Choose a number to shift by. It could be, we chose 5. It could be 10, 11, whatever number you like, okay? And then shift it over, and then hand it to your friend, and see if they can work out, number 1, what number did they choose? And number 2, what's the message supposed to be? Okay? So write out your own message, obviously not too long, because just a sentence, because it'll take too long to do this, okay? Pick your own number, shift everything over, use your cipher on it, encrypt it, and hand it to your friend and see if they can undo it. Off you go.